Hello and welcome to another malware forensic analysis video. Following on from the last one, in the last video we were looking at a polymorphic malware sample called Virut.ce, and we ran that sample through some tools to try and unpack the outer layers of it. We found out that within that, packed with that virus, there is another piece of malware called Zango that seems to infect Internet Explorer in some way. What we're going to try and do in this video is we're going to take this sample, we're going to treat it as though we're in a major incident within an organization. We don't care about the techniques used to pack it or it uses to spread. In this case, we're just worried about what information it may have leaked from our organization. So we're just interested in the payload that it unpacks and then starts to execute. So what we're going to do is we're going to run this malware in our lab. We're going to attach Ollie DB, Ollie debug up to it. We're going to dump out the memory. That memory will it'll be all unlinked and it'll be broken. We'll never be able to run that as a program again on here, but what it will do is it'll allow us to load it into another program and just have a little poke around and see exactly what it's doing, what it's leaking out, and what we can do there. The second part of this video, if we've got time, we will try and bait this malware into infecting another file. Because it's got several different strains of malware in this one file, it kind of pollutes our output when we're trying to analyze it. So if we were looking at it from a flip side, which is look at how it unpacks and then build our own signature for our own IDS or firewall on top, we would need to be able to understand more about just how that polymorphic engine works at unpacking it and repacking it. So what we'll do is we'll bait it to infect another file, and then we've got an infected file that will be able to run, that will just have that virus in it. And because we know the contents of that original file, we'll be able to differentiate between our code and the newly infected code. So initially, let's run this malware and try and dump it out and just have a little look a little bit more at what the payload's doing. So let's execute that malware, see what it does. Okay, so it's running now. Again, it's showing up as packed, so that's fine. We'll go to Ollie and load in. It looks like I've been trying to load Ollie into Ollie, so we'll have to let it stop doing that in a minute. Okay, so what we'll do is we'll attach to that process that's running. If we can find it, there it is. So malware, it's got form 1. During the last video we noticed that Zango, which was the IE malware, loaded up a Visual Basic form, so that's a good indicator that that's running. Yep, that's fine, just because I was having a look at checking out Ollie earlier. Okay, so we're now attached to that process. Let's dump out the memory. So if we save the data to a file, we'll just load it onto the desktop, and we'll call this malware Ollie dump. And that malware is still going to be running, so we kind of want to stop it. I know it's got a load of anti-debug stuff built into it, so I think if we just shut down Ollie, it'll probably kill it off. Yeah, okay, that killed off the process. That's good. So let's load that in. Have a look at and see if it gives us a little bit more information about the payload and what it's doing. So where is that? There it is. Okay. So it's coming up as a binary file, which is fine. It's completely broken, so there's no way that we'll be able to relink this and run this, because it'll just be a nightmare, and it probably won't be quite the same ever again. All of this is probably going to be quite useless to try and go through. The hex view might be a better option. So again, if we ran another hex editor such as HXD, just loaded our program in there. here, is it? Just to make that a bit easier to look at. So this should be our unencrypted payload. It doesn't necessarily mean it's not still obfuscated, so it might still be a bit difficult to read. This looks promising. So we noticed in the initial run that there was this connection to this IRC address here. Looks like there's a second one in there as well. Looks like there's a nickname. Looks like there's even an obfuscated user in there. So we could potentially, I mean this is an old piece of malware. These command and control servers will be down and long gone by now. But we could have connected in and had a look. Let's go to the strings view on here, as it might be a little bit easier to read these. Oh, there we go. So these are the two IRC servers that it can connect to. Probably what it does is it swaps these out between infections. That way, if one of these gets owned or gets taken down, then more than likely in the future, when a future infection happens and it rotates to this other one, that this one might work. We're given some sort of nickname here. I don't know if that changes during infection or what. And it looks like it's got some messages to join channels and stuff. So it looks like we've actually got access to the payload here, which is good. Again, going back to our hex editor. You know, we've got some checks and changes to privileges here. So this might be what it's doing during reinfection. Excuse me. Yeah, I think that's kind of the extent of my hex skills here. So I'm not going to be able to pull a lot more information out of that, I'm afraid. So that is probably enough for us to kind of dig into a little bit more detail during a major incident. I could probably hook in here and just see what command is being told, if it's being asked to upload all of my specific set of my files, and I know none of those exist in the organisation. Well, to me that risk is mitigated a little bit more. I can also tune my my gateways out to block connections to these particular hosts. Now I know both of them. Before I would have only known about this one. On reinfection, it might have used this one. I can block IRC out if I really want to, if I know that it's not being used by the rest of the organisation. So there's those kind of things that can be done. The only other thing that I wanted to do, part of this video, was say that we now want to take a look at this malware in a bit more detail. But when I disassemble this malware to have a look at how its packer works, I'm greeted with not just this not just the polymorphic Virut.ce's malware. I've got other ones in here such as Zango and other things all packed into one. So what I want to do now is I want to bait this malware into infecting another program. So if I wind this machine back now, before I actually executed it, and we're back. Okay, so what I want to do is I have a test program on here. This test program is written in assembly, so it's absolutely tiny. So I can differentiate the stuff that I know it's executing against what's being injected into it by an infection. What we can do, what I'll do is all of this code will be on my GitHub account, and I'll put a link to it in the show notes, so you can use it if you want. If we have a quick look, so MD5 and that is assembling, blah. Okay, that's good. So let's open that up. In our favourite HXD. So, looking at the program, it's absolutely tiny. All we've got here is saying that it's a portable executable. It's it's got some areas in it that it's declaring. It's got our data. It's got data, and really and truly, all it's doing is when it executes, it's just running a message box that says goodbye world. And I leave this. I've put it so that it's on a button, so it stays open. So if I wanted to again dump this out in Ollie, I could execute this, and then it would stay running while I then dump it out. So that should still have the same code. That's lovely. In IDA, again, that program looks fairly straightforward. It's a tiny program. So it's got one system that uses a message box. So that's all that we would need to ignore when we look at the infected program. So let's infect it. So let's run malware. Okay, let's see if that's already infected that program. Okay, it's already infected it, so it's seen it, it's infected it. Now let's kill it. And let's load that back into... Let's look at it in the hex editor first. Which I showed. Okay, so we've got what we had before, our standard portable executable file. A little bit more. No, that's the same. Goodbye world. And at the bottom, we've got all of this extra data, which looks to be our encrypted payload, and somewhere in there will be an obfuscated stub that will decrypt that. And in IDA, we'll load more functions now. So where does it start? So that then jumps down to here. Jumps down again. Jumps down again. Jumps down again. So it looks like the pointers are jumping straight into the stub now, because the message box isn't being executed straight away. So it's not executing the original program and then the stub. It looks like it points straight to the stub now. So our program is up here. Okay, that's good. Yep. I mean, excellent. So you'll be we're now at the position where we can, if we wanted to, we could start trying to break down what some of this stuff does. If you've got a Hexrays plugin, you could convert this to pseudocode, try and work out what on earth this is doing, which I'll probably do in a later video when I've got a bit more time. But that's all I really wanted to do with this video, was get to those 2 points. So in this video, we've been able to run the original executable and dump it out using Ollie debug, and we've been able to figure out where it's calling out to or where it could possibly call out to on infections to a command and control server, so we can filter that out on a perimeter firewall or some sort of proxy device along the way. We've also been able to get the malware, we've baited it to infect a test file that we know the contents of, so we can have a look at the decryption stub unencumbered by other infected parts of the original sample. So thank you very much for watching. If you've got any comments, then please place them below, and if you like this video or you'd like more like it, then please feel free to comment and or like and subscribe. Thank you for watching.